So this first group of identities, this is really nothing new. It's just sometimes we don't think of it this way, right? So we know that cosecant is 1 over sine, right? Cosecant is the reciprocal of sine. Well, it works the other way also. That means that sine is 1 over cosecant. So these are called our reciprocal identities, okay? Okay, and in this column, these are the 3 that we're comfortable with, and at least we should be comfortable with, and we're familiar with. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Okay, those are the 3 that we're familiar with. And then these are the 3 that we could have figured out, but it's just not as natural to us, right? So if cosecant is 1 over sine, then that means sine is 1 over cosecant. If secant is 1 over cosine, then that means cosine is 1 over secant. And then, of course, cotangent is 1 over tangent. So that means that tangent is 1 over cosine, right? So those should come pretty natural to us. I don't know about you guys, I can't stand a dirty computer screen. So in my other school before I moved to Florida, I was a technology coordinator. So we had just started, like all the kids just had Chromebooks like for a couple years. Well, the school I taught at was a 7th through 12th grade. And sometimes I'd have to fix some of the Chromebooks if something went wrong with them. 7th graders, oh my word, they are the dirtiest human beings on the face of the earth. Their Chromebooks would be so disgustingly filthy. It's like, oh my word. So it's like before I even touched their Chromebook, I'd have to clean it and spray Lysol on it. They were just so filthy. I'm telling you, 7th grade boys, it's an absolute miracle that you guys survived 7th grade. It is like, I don't know how 7th grade boys even survive. They're so filthy. Just like they'll sit there in the class, their nose will just be running. Like, it's like, oh my word. It's so, oh my goodness. God made me a high school teacher for a reason because 7th grade boys are disgusting. They really are. And 7th grade girls like to point out that the 7th grade boys are disgusting. Ew, you're so gross. Oh my word. It's a miracle that we survived middle school. Okay. So here's 2 more identities. Okay. These are called the quotient identities. We know that tangent is y over x. We know that from our unit circle. Well, if we think about it, y refers to the sine, x refers to cosine. So if we know that tangent is y over x from our unit circle, then we know that tangent is sine over cosine. Okay, tangent is sine over cosine, which means cotangent is cosine over sine. Okay. Those are called the quotient identities. It doesn't matter. You don't need to know what they're called. They do have a name. Tangent is sine over cosine. Cotangent is cosine over sine. Okay. Okay. Now the Pythagorean identities, right? So we know the Pythagorean theorem refers to right triangles. Oops, let me draw that differently. Okay. The Pythagorean theorem refers to right triangles. Right? Here's my x, here's my y, and we'll call this z, right? So according to the Pythagorean theorem, x squared plus y squared equals z squared, okay? Well, let's apply that to our unit circle. Okay. So in our unit circle, what does the x refer to? Which trig value? Cosine. So instead of x squared, we're going to say cosine squared. Cosine squared u. Okay, u just refers to the angle. And instead of y, we'll say sine. So cosine squared plus y sine squared equals. Now on our unit circle, what's this z going to be? 1. So it equals 1 squared, which is 1. That is our first Pythagorean identity, and that's where it comes from, Pythagorean theorem, x squared plus y squared equals z squared, which translates to cosine squared plus sine squared equals 1. Okay. Now, from there, we can come up with a whole bunch of others. I only memorized that one because the other ones I can figure out. Okay. So, for instance, this means that cosine squared is equal to 1 minus sine squared. And it means that sine squared is equal to 1 minus cosine squared. Okay? Okay. Let's look at another variation. Look at the yellow one. What if I divided everything by cosine squared? What's cosine squared divided by cosine squared? 1. Okay, how about sine squared divided by sine squared? What's sine? I'm sorry, I said it wrong. You're right, but I said it wrong. Divide everything by cosine squared. What is sine squared divided by cosine squared? Tangent squared, right, because sine over cosine is tangent. So this will be tangent squared. What is 1 divided by cosine squared? Secant, yes. So there's our next Pythagorean identity. And all I did was divide everything by cosine squared. Okay? And then, of course, this means, right, this means that 1 is equal to secant squared, oops, let's try that again, secant squared minus tangent squared, right? And it means tangent squared is equal to secant squared minus 1. Okay, again, I don't memorize these. I just try to recognize them. Like anytime I have two trig functions that are squared and a 1 in the equation, I'm thinking somehow it's got to be a Pythagorean identity. And I just kind of manipulate it to figure that out, okay? Okay, so let's use the same type of reasoning. Let's divide that original Pythagorean identity. This is the original one, right? This is the one everyone's expected to know right off the top of their head. Instead of dividing everything by cosine squared, let's divide everything by sine squared. And what would we get? Cosine squared divided by sine squared gives us cotangent squared, right? We're dividing everything by sine squared. So sine squared divided by sine squared is 1. And then we have 1 divided by sine squared, which is cosecant squared. Okay. See if you can come up with the other two identities that come from this one. Okay, so I'm going to subtract 1 from both sides. So cotangent squared equals cosecant squared minus 1. And we can have 1 equals cosecant squared minus cotangent squared. Okay? Those are our Pythagorean identities. And you just, so looking at the yellow ones, right? I know the original, the fundamental Pythagorean identity. The other two yellow ones come from dividing everything by cosine squared or dividing everything by sine squared. The white ones are just a matter of rearranging them. Okay? Okay. Let's look at what we call the co-function identities. Mm-hmm.
The yellow is like your answer, the white would be like different ways of come.
Yes.
Oh, yeah. I thought we were like learning like 9 different things.
Nope. Like I say, I only memorized the one. Cosine squared plus sine squared equals 1. The others I can just figure out.
Right.
Okay. Okay, co-function identities. So we've actually kind of, I think we've looked at this. I always forget whether I did it with your class or the 6th period. But the co-function identities, before I actually tell you the identities, let's look at the unit circle again. What is the sine of 30 degrees? What's the sine of 30 degrees?
Square 2.
No. Sine of 30 degrees. 1/2, yes. Okay. What is the cosine of 60 degrees? Okay. What is the sine of 60 degrees?
Right.
Square root 3 over 2. How about the cosine of 30 degrees? Okay, do you see a pattern here? What's the pattern? Not the opposite. I know what you're saying. It's the complement, right?
Yeah.
Okay. So basically, these are what we call co-function identities. And what that means is that the sine of u is equal to the cosine of 90 minus u. So the sine of an angle is equal to the cosine of its complement. This shows up on your SAT every once in a while in some form. In fact, it was on the last SAT. Okay, and the way it was on the last SAT was some complicated looking problem, right? And they gave you this they said that you had this right triangle. I forget the letters. It was like A, B, and C. And they told you that this was a right angle. And they said that there was some point Q between A and C, right? And then I forget exactly how they phrased it, but basically they said something about the angle ABQ and the angle CBQ, right? So we're talking about this angle and this angle. And then they said, what is the sine of ABQ minus the cosine of CBQ? It was something like that. So we'll call this X and we'll call this Y. They said, what's the sine of X minus the cosine of Y? This is a cofunction problem because these two angles add up to 90 degrees, which means they're complements of each other. So the sine of this angle is equal to the cosine of 90 minus that angle. Well, 90, here's 90, minus this angle, that equals y. So the sine of x is actually equal to the cosine of y. So sine x minus cosine y was equal to 0. So this was a and this was one of those. I think just about every student that asked me about this was like, "What in the world? How are we supposed to know that?" And it's like, "Oh yeah, that's a trig problem," and you don't even know that it's a trig problem, but now you know, okay? Because you see 90 degrees on a triangle. Start thinking trig, okay? So that was the trick there. That was a co-function identity, okay? So in other words, the sine of 20 is equal to the cosine of what? So 70. Sine of 20 is equal to the cosine of 70. Okay. How about the cosine of 85? What does that equal to? Sine of 5. Okay. Co-function identities. So this is going to extend beyond just sine and cosine. So let me write this. Cosine of u will equal sine of 90 minus u. And then we've got the tangent of u is equal to the cotangent of 90 minus u. Okay, and then we've got, let me see here. Cosecant of u is equal to the secant of 90 minus u. And secant of u is equal to the cosecant of 90 minus u. And then, of course, cotangent u is equal to the tangent of 90 minus u. Okay, and we can write these using radians, right? Sine u equals cosine pi over 2 minus u, right? And that translates all the way down. Instead of 90, we say pi over 2. Okay. 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 Co-function identity. So we should recognize those, okay? And the last group is what we call the even odd functions. So sine of negative u is equal to negative sine u. These are kind of weird. Okay, so let's just think about what that's actually saying. Right? So let's look at the sine of negative 60 degrees, right? Sine of negative u. Well, here's the sine of negative 60 right here. Negative 60. The coordinate there is 1/2 negative root 3 over 2. Okay. This identity is saying that that is equivalent to negative sine of 60. Well, let's look at that. Here's sine of 60 up here. And the coordinate there is 1/2 root 3 over 2. So the sine of 60 is root 3 over 2. Negative sine of 60 is negative root 3 over 2. That's equal to sine of negative 60. Okay. So if I'm taking the sine of a negative angle, I just have to think of the sine of the angle and then take the opposite of that, the opposite sine of it, okay? So that means that cosecant of negative u is equal to negative cosecant. Now let's look at cosine. If I take the cosine of negative 60, that equals 1/2. How does that relate to the cosine of positive 60? They're the same. Cosine of positive 60 is 1/2. So when we look at cosine of a negative angle, that's the same as cosine of the positive angle. So it doesn't matter that it's a negative angle when we're talking about cosine. Okay. Same thing happens when we're talking about secant. It doesn't matter that it's the negative angle if we're looking at secant. Okay. What about tangent? Do you think it'll matter with tangent? Look at our negative 60 as our example. Yeah, it matters. So this is going to equal what? Negative tangent. And the same thing for cotangent. Okay. So the two that are unique here are the cosine and the secant ones. Okay. Okay. All right, that's it for our list of identities. I'm going to take a little break before we start doing the next section. Okay. Let's see here. Okay.
Wait a minute.
Okay, so we are going to use these identities to simplify trigonometric expressions and ultimately to help us when we solve equations. So for instance, let's say I have sine x times cosine squared minus sine x. Okay. So I want to simplify this trigonometric expression. So look at the identities that we just learned. Can we change that? Usually if I have more than one trig function in the expression, I'm going to want to simplify it so that I only have one trig function. So I have sine and cosine. So if I can simplify that so that I'm only looking at cosines or I'm only looking at sines, it would be better.
You just cancel out the two signs.
Can't cancel out the two signs. Nope. I can't divide it by sign. If there was an equal sign, then maybe I could, but this is just an expression. So what do we know about cosine squared? Anytime you see something squared, think Pythagorean. Okay, that's not too bad. What does cosine equal? What does cosine squared equal? 1 minus sine squared, right. So if I rewrite this as sine x and then times cosine squared, which is 1 minus sine squared, minus sine x. I could do that. So now I have sine x minus sine cubed x. Right, I'm distributing the sine x minus sine x. I have sine x minus sine x, so this just equals negative sine cubed x. And now it is simplified. So we can even check this on our calculator to see if it's correct. Okay. So I'm going to go on my calculator. And so let's see. We've got the original was sine x cosine squared, right? So sine x. It doesn't matter. Okay. Cosine. Now remember your calculator, right? So when I wrote cosine squared x, the square came after the cosine, but the calculator doesn't allow you to do that. So after we close the parentheses, then we're going to make it squared like that. Okay. And then it's going to be minus sine x. Okay. Let me see. I am in radian mode, so I'm going to just make sure that my window is in radian, and it is. That's negative 2 pi, and that's 2 pi. Right? So when I graph it, okay, there's the function. All right. So what I want to do is see whether or not I simplified it correctly. So I'm going to put negative sine x cubed. So if I simplified it correctly, these should be exactly the same graph because they're equivalent. Okay. And sure enough, they are. So that means we simplified it correctly. Everyone able to do that? Anthony, you look like you did not do it.
It says check done.
Okay, so go to your window. Are you in radian mode?
Yeah, I got like 10 for everything.
Okay, so that's not radian mode. So press your mode button and check to see if you're in radian. You're in degree? Okay, that's fine. So go to your window. If you're in degree, okay, I'm going to change mine to degree also. Okay. If we're in degree mode,
You gotta be in radians.
you can be in either. You just have to change your window. So I'm going to make this negative 360 to positive 360. Instead of 2 pi, we're using 360. And our scalar will be 60 degrees. Okay? And then y, I went from negative 5 to 5. You could do 10 to 10, doesn't matter. And then graph it. We get the same thing if we're in degree mode. So if you're in degree mode, you want to use 360 and negative 360. If you're in radian mode, you want to use 2 pi and negative 2 pi. Okay. Did it work this time?
Can I just show you what it seems? I don't
Okay, I know what it's doing. Go to your y equals, and at the top here, are these plots lit up?
I think this Cole had my calculator before break.
Okay. Do you see these plots up top? Are they lit up? Is one of them highlighted?
Yes, the first one.
Then go up to the first one and press enter to unhighlight it. Your stat plot is on. Do you have statistics?
Yeah.
Okay, you were probably doing something in statistics, so your stat plot is on. Try it now. Okay, bring.
There you go. I got it.
Yay! All right. So just remember, because you do have statistics, and that'll happen a lot. If you get an invalid dim error, usually it's because one of these plots is lit up, which means your stat plot is still on. Okay, you just have to unselect it. Anyone else having trouble? Okay. All right, so let's go back. Let's look at another one. Let's simplify. No, I don't want to do that one. Yeah, these are all kind of weird. Oh, here's one. Okay. How about this one? Let's do 4 tangent squared x plus tangent x. Oh, that's a bad one. Shoot. I'm trying to find an easy one, and I'm not being successful here. Okay.
4.
Let's do this. Okay, let's look at this worksheet together. Okay. So what we're going to do is what we call verify our identities, all right? So if we look at that first one, we've got secant x over sine squared x equals cosecant squared x over cosine x, okay? When we're asked to verify an identity, that means we want to show or prove that the left side is equal to the right side, okay? So we're going to use the identities that we know in order to simplify this, to simplify both sides. We just have to get them to be the same on both sides, okay? What we have to avoid, because our temptation is to cross multiply. Right? We're not solving this. We are verifying that these two sides are equivalent. So I have to work with one side by itself and then with the other side by itself. And we want to get the two sides to be exactly the same. We're not solving it, so we're not going to cross multiply. That tends to be what we want to do because that's what we're used to. Okay? So what do we know about secant? 1 over sine. Okay, so let's change that to 1 over sine. 1 over cosine. Sorry. 1 over cosine. All right? What do we know about sine? Or sine squared, I should say. One minus cosine squared. Good. Okay, so let's rewrite sine squared as 1 minus cosine squared x. Okay. So I haven't done anything to the right side yet, but I do notice, I feel like I'm on the right track because this is cosine over here. Now at least I've got things in terms of cosine, all right? So I'm still working on the left side. I'm going to rewrite this as 1 over cosine x times, right? This is a fraction within a fraction, so this will be times 1 over 1 minus cosine squared x. Okay, so let's see, that gives me 1 over, right? If I multiply cosine times 1 minus cosine, that's going to give me cosine x minus cosine cubed x. Okay, I don't know if that's helping me or not, okay? So is that equal to cosecant squared x over cosine x? That's the big question, right? So what do we know about cosecant squared x?
It's inverse.
Where's my Pythagorean? Cosecant squared x is 1, cotangent x plus 1, right? Cotangent x plus 1. Is that helping me any? That is not helping me any. Okay. Yeah.
When you multiply, why is 1 minus cosine squared x on the bottom if you divide it above it? Shouldn't it be flipped?
Now this is correct because this is over 1, right? So when I flip and multiply, it becomes times 1 over cosine squared x.
Oh, okay.
Yeah. Okay, so it's a shame that I started with this one, but that's okay. So sometimes what happens is when you work on one side, right, it starts to get more complex instead of simplifying, right? When that happens, it's time to go back and say, okay, let me try a different approach because it didn't simplify. It got worse, right? This is getting worse. It's getting more complex. So I'm going to go back up and I'm going to say, you know what? Instead of starting with the left side, let's start with the right side and see if I can do anything with that one instead. Okay, so I'm going to go ahead and scratch what I was doing because it was getting more complicated, and that does happen. So it's good that we saw that, but unfortunate that it was on the first one. But that's okay. So this time I'm going to work with the right side. Okay. And what was your first instinct when you saw cosecant? Instead of doing the 1 minus cotangent, what were you thinking? What's cosecant? 1 over sine, right? So we can write this as 1 over sine x. And already I can see that that's looking good. Okay. Why do I feel like that's looking better already? Yeah, exactly. So what do we do with this cosine here? This is cosine over 1, right? So let's rewrite it as 1 over sine squared x times 1 over cosine x. So the whole time I'm doing this, I'm looking at the other side, okay? So looking at the other side, I already have a sine squared in the denominator, which is really good because I have a sine squared in the denominator here. So now looking at the other side, I'm going to rewrite that secant as 1 over cosine. Right? So this is over 1, so that means I'm going to have 1 over cosine x times 1 over sine squared, and now I've got the same thing on both sides. So check mark, we proved that they're the same. We proved that they're equal. Okay? So our first attack or our first approach was to use the Pythagorean identities because I saw that this was a sine squared, but that ended up making it more complicated. Okay. As I was stepping through, it was getting more complicated. If it's getting more complicated, you're probably choosing the wrong path. Okay. Just like, if you're trying to find that cabin in the woods and the path that you take starts getting more and more difficult and more overgrown, you're like, okay, this can't be right. So you go back to your starting point and you choose a different path. Okay, that's what we did. It was getting more complicated, so we went, okay, let's go back to the start and choose a different path. So we looked at the other side and tried something different. Okay. Okay. Let's look at the next one. Right? We're verifying identities. So that means all we're looking to do is get the left and the right side to be the same. Okay. So we're looking at tangent x plus secant x over secant x equals sine x plus 1. Okay. So looking at this one, there's not really much I can do on the right. I can't simplify the sign at all. Okay, so we've got to work on the left. So let's see here. First, I am going to separate these. Make it tangent x over secant x plus secant x over secant x. And right away, I see that was a good move. How do I see that? Yeah, secant x over secant x is 1, right. So there's my 1, that's good. But the tangent, I need it to be just plain old sine. So can I write tangent in terms of sine? Tangent is sine x over cosine x. So there's my tangent. What about secant? That's 1 over cosine. Okay. Now what? Right, we're going to flip and multiply. Notice how I keep putting that equal sign there, right? Because I'm just working with the left side. I'm leaving the right alone. Okay. So now we can see our cosines are going to cancel, and we're left with sine x over 1 plus 1, and that equals sine x plus 1, and we're finished. Okay. Usually, you want to get whatever you have down to sine and cosines. Usually. Okay. Okay, so for homework, you're going to do the remaining 3. Remember, start with one side and try to just work with one side. Okay? Sometimes you have to go and do both sides, but try just using one side to start with.